speaking of being a shallow male, all right, so most of the shallow males here have a little black book. Hopefully, if they're smart, they have a black book inside their brains and not an actual black book, which one of my students back a long time ago actually did. Yes, he had a spiral bound notebook where he had rated rated all the girls of the sophomore class. Okay, and that's okay if you keep it in your bedroom. When you bring it to school to show off to your guy friends and leave it under one of my desks to be found by a female sophomore. No. All I found, I came into the room because I had gone to the bathroom. I came into the room and there was like a mass of girls surrounding this girl holding a spiral bound notebook. And they were going, oh my gosh, ooh, oh. And I'm going, oh my God. So I go, let me have that. And they gave it to me. I'm going, this boy is dead. So I called our only female administrator at the time, who was a referee for basketball, and she was tough as nails. And she came and got him and took him away for his own protection. She gave him a 2-day suspension just to kind of get things to calm down, because they had actually rated him on the last page. It wasn't nice. It wasn't a good rating. All right. Why am I saying this? There's always a reason for my insanity, right? Well, there is a little black book in chemistry. It's called the electronegativity chart. So turn to the back of your periodic table, which of course should be out because every day we have the periodic table out. Every day we use it. And more often than not, I have to remind you to take out your periodic table. So, electronegativity is the ability of an atom in a molecule to attract electrons to itself. In other words, how attractive an element is. It's a rating system from 0 to 4. From 0 to 4. Where 4 is drop dead gorgeous. Okay? So Malachi, this is going to be really cool because she won't know anything about this. So when you see Maddie, I want you to go up to, I want you to be calling her on the phone saying, Maddie, I just want to tell you, you are a 4.0 girl. You are a 4.0. And what will he basically be telling her? She is as beautiful as she can be. She is, yes. Well, then she will know that Malachi thinks that she's the most beautiful creature on earth. Okay? Who has a 4.0? Fluorine. Fluorine. FR, on the other hand, is OMG. Ugly. I mean, Maddie's beauty might just be skin deep, but OMG, francium's ugliness goes all the way to the bone. Okay? Francium is the ugliest element on the periodic table. Francium is the ugliest element on the periodic table. So here it is. Francium. Okay? So, Emma, what would happen if francium came and said, hey, Emma, I'd like to date you. What do you think? What do you think about that? As, a little boogers, just a little stream of boogers coming down his right nostril. What do you think? What do you think? What would you say? What would you say? What? Oh, that is cold. You just turn around and leave just because he's so ugly. Okay, so Emma, what if oxygen came up to you and said, hey, baby, I'd like to date you. When and where? Yes, she does understand. Oxygen is so attractive that it's going to attract electrons to it. And that's the key. And folks, how does it relate to atomic radius? Absolute opposite. Like I told you, all you have to remember is atomic radius. Anything else is going to be opposite. So notice what happens to atomic radius as you go from left to right. It gets smaller. So what happens to electronegativity? It gets bigger. So what is the electronegativity like for metals? Let's look. Let's check it out. Okay, here's the zigzag line. By and large, metals are ugly. What about non-metals? Purdy. They're the purdies. Yeah, it's not perfect. So metals have high electronegativity. Non-metals have low electronegativity. Okay, so let's get back to our analogy. Who did we use as an analogy? No, we didn't use Malachi because he was going to get in trouble. All right, so here we go. So, Betty, okay, who was probably very beautiful when she was, well, let's just say in her 60s, you know, but now she's in her 90s. So Betty is 0.7, okay? Christian. So Betty and Christian are dating, okay? And here comes, I was told it should be called Summer. No, Summer. What? Summer. Oh, Summer. Okay, Summer. I saw a picture of her. I don't know. I'd give her a 3.2. All right, so Christian, you're dating somebody that's 0.7. 3.2 wants to date you. Your choices are, do you date them both? Or do you leave the 0.7? Or do you stay with 0.7? Leave. Okay, so this is an example of an ionic bond. When an electron is presently with a very ugly element and a very good-looking element comes around, one whose electronegativity is very high, what's going to happen? The electron will leave the low electronegative one and go to the high electronegative one. Okay? And that is why ionics form. Ionics form between two nuclei. One is ugly, the other one is very good looking. All right, scenario number 2. Summer, and fall.
I like that.
All right, and here is Christian. And 3.2, 3.2. So Christian, both girls want you. They want you bad. They want you to date them so you can go, they can play ping pong with you and bowl and putt-putt. Fun stuff to do with girls. All right? So what would you do? Would you go with Summer, 3.2, leave Fall behind? Would you date them both, but spend more time with Summer because you like Summer before, you know, it's warmer? Or say, girls, there's enough of me to go around. Okay, how about if you share me equally? 3.5 days for Summer, 3.5 days for Fall. What's it going to be? That's right. So what happens is we would find that Christian would be evenly distributed between these two. Evenly distributed between these two. Okay, evenly distributed between those two, which means Christian is just as likely to be on one side as the other. We're not messing with cell phones, Bobby. All right, so that results in a non-polar bond. So when the electronegativity difference is basically the same, you have a non-polar bond. Non-polar bond. But, third scenario. Summer with what I think is a 3.2. And how about Sammy with a 3.0? Sammy's that girl you've been in love with since the beginning of the year, and Summer's new in your life. So you find out that Sammy wanted to date you. Yeah, sure. Okay, but, I mean, Summer's better looking. She is, isn't she? Okay, so what are you going to do? You're going to spend time even Stevens between these two good-looking gals, or are you going to spend more time with Summer? So we find that most of the time Christian's over here, but every once in a while he's over here. But most of the time he's over here, but sometimes he spends time with Sammy, but most of the time he's over here, but every once in a while he's over here. So the side where Christian is more than likely to be, we say, has a negative pole to it. The side where Christian might be, but not as likely, we say has a positive side to it. So pole. So we have two poles, which we call a polar molecule. So when one electronegativity is high and the other one is almost exactly the same highness, what do we have? Non-polar. Very good, Zach. When one is very, very low, like unbelievably low, like extremely low, like so low it goes all the way to the bone low, and the other one is really, really high, we have ionic compound. Good job, Freddie. And when we have one is really, really pretty and the other one is just really pretty instead of really, really, we have polar. So if you don't have much difference at all, you're going to have a non-polar covalent bond. The more difference you have, the more polar it becomes, until finally the difference is so great that Christian's going to leave the ugly one and go just single date the pretty one. Okay? Then you have ionic. Okay, if I'm correct, this may be the greatest science video of all time.
Atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom.
Okay, so the Christian, of course, is the little chew toy, and notice how one dog took Christian from the other. That results in an ionic bond.
Results in a positively charged ion called a cation and a negatively charged ion called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons.
Notice how they're sharing the tug toy equally. What kind of bond is this?
By two
Non-polar.
atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
Okay. By this time, you guys have seen hundreds of science videos. Is that not the greatest science video of all time? All right, look at these three. Which one is ionic? Which one is nonpolar? Which one is polar? The blue represents Christian, all the places Christian can be. Let's see. Reagan, which one's ionic? That's right. C. Why? Because they've taken Christians and they've split them up, and so one of them has most of the Christians and the other one has very few Christians. All right. Sierra, which one is polar? And it can't be C. A, where Christian appears to be equally distributed between these two. I'm going to try again. What did I say? Did I say polar or non-polar? Polar. Okay, so here Christian looks like he's equally distributed. Polar means you got a positive side and a negative side. That's polar. And finally, non-polar is, okay, one more. This is not nearly as exciting. It's more of a traditional science video. All right, so get ready.
When forming compounds, atoms tend to gain, lose,
bad.
or share electrons to achieve a stable noble gas electron configuration, an octet of electrons. In ionic bonding, an octet is formed by transferring one or more valence electrons from one atom to another. In covalent bonding, an octet is formed by sharing valence electrons between atoms. Sodium has 1 valence electron and fluorine has 7 valence electrons. If the 1 valence electron of sodium is transferred to fluorine, both atoms achieve an octet of electrons. By losing 1 electron, sodium has a +1 charge. By gaining 1 electron, fluorine has a -1 charge. An ionic bond is the electrostatic force that holds ions together in ionic compounds. Both fluorine atoms have 7 valence electrons. If 1 electron from each fluorine atom is shared with the other atom, then both fluorine atoms achieve an octet of electrons. This type of bond is called a nonpolar covalent bond. The sharing of electrons between atoms is exactly equal, and the electron density is symmetrical. The distribution varies according to the colors of the rainbow. The most electron-rich region is shown in red, in this case the region between the 2 nuclei, and the most electron-poor region is blue. Hydrogen has 1 valence electron.
Okay, so notice with a non-polar, notice how the most electrons are right in between them, evenly distributed.
And fluorine has 7 valence electrons. If the 1 valence electron of hydrogen is shared with 7 valence electrons in fluorine, fluorine achieves an octet of electrons. Note that hydrogen has only 2 electrons, which is the electron configuration of helium. When bonded to another element, hydrogen will have 2 electrons in its valence shell. In this bond, fluorine has a greater attraction for the electrons in the bond, a greater electronegativity. Because the electrons spend more time near the fluorine atom, the electron density shifts towards fluorine. The most electron-rich region is red, the most electron-poor region is blue. The result is a greater electron density near fluorine, a partial negative charge, and a correspondingly lower electron density near hydrogen, a partial positive charge. This type of bond, where bonding electrons are unequally shared, is called a polar covalent bond. A polar covalent bond can be thought of.
Notice the red is where most of the electrons are located. They are on fluorine side, okay, giving us a polar bond. All right, so let's practice. Keep an eye on that electronegativity chart. It's on the back of your periodic table. You see it? It's about right in the middle, maybe a little bit left of the middle. Got it? Okay, so this is how you do this one. These. Look up H. H electronegativity is 2.2. Phosphorus. 2.2 for a difference of 0. Hydrogen, still 2.2. Carbon, for a difference of 0.4. The polar one is the one that's going to have the greatest difference. So which one of these two has the greatest difference? Hip or hick? All right. Try of or oi. Of or oi. Oxygen is 3.5. Fluorine is 4.0. What's iodine?
2.7.
So a difference of versus. So who has the greatest difference? All right, now you see how this works. Try the last two by yourselves. All right, no or so? That is so correct. Ne or si? A molecule that is polar is said to have two poles. So we call them a dipole. We say they have a dipole moment. In other words, at any time, at any moment, if you were to take a snapshot of them, you would find that most of the electrons are on one side rather than the other. So it has a dipole moment. It is represented with an arrow and then a plus on the other side. The arrow refers to the element is always pointing toward the element that is the most electronegative. And how do you find which one's the most electronegative? The chart. The chart. Okay? Then, so the one that you point toward, that's the negative side. This part right here tells you which one is the positive side. So you always point toward the negative side, and then the other side is a positive side. Let me give you an example. Oxygen is 3.5, hydrogen is 2.2. So who do we point the arrow toward? So because hydrogen is on the same side, then this is the positive side and this is the negative side of water. What are some examples of molecules that have dipole moments? All polar molecules. And what kind of characteristics will they have? High surface tension, high melting point, high boiling point, and water is known as the universal solvent. Water is a superhero of polar molecules. Water is the most polar of all the polar molecules. So water is going to have some superhero type characteristics. All the molecules that are like water are the complete opposite. They have no surface tension. They have low melting points. They have low boiling points. They cannot dissolve anything. Water is unique. We'll finish by letting me show you this video that takes you through the different attributes of water. And I'll explain to you once again why it is so unique. 2 minutes?